Let's talk about the convergence tests with series. In this video, we're going to talk the divergence test, sometimes referred to as the nth term test. Now, the nth term test can only be used to show that something diverges. And here's, in a very quick nutshell, what it says. If you just look at the function that is inside your series and you just say, what's the limit of that as I go to infinity? Well, in this case, we have the same power on the top and bottom, so we use those coefficients, and we say, well, the limit is 2/5. Okay, the limit is 2/5. Well, in this case, then, if the limit isn't even 0, because it's a sum, this is saying I'm just going to add something that's approximately 2/5 for an infinite number of terms. Well, then automatically this diverges. You can't be adding 2/5 over and over and over again. So let's do this next one. We say, well, what's the limit here as n goes to infinity? Well, in this case, you see the high power is on top, so that limit is infinity. Well, you're adding an infinite size term every time this diverges. So again, anytime the limit isn't 0, it means you're continuously adding something. Now, unfortunately, like with this example, you say, well, what's the limit as n goes to infinity? Well, the high power is on the bottom. So here you say, well, the limit is 0. But the divergence test gets its name because it cannot prove convergence. A situation like this, where the limit actually is 0, this just means we don't know. It's inconclusive. Okay? So we can only prove a series diverges if the limit of the function inside is not 0. Let's try some. All right, I've put 4 examples here. You're going to want to just say, does it diverge, or does this test not work and it's inconclusive? Pause here and try them. All right, let's quickly go through these. We've got a limit as n goes to infinity. We check that. Well, same power on top and bottom, so the limit is 4/3. Well, if it's not 0, we diverge. Next, we take the limit as n goes to infinity. You can see the higher powered function is actually in the numerator. You could do that with L'Hopital's rule too and check it, but that limit then is infinite. Well, this diverges. The limit isn't 0, it diverges. Here, we take the limit as n goes to infinity. Well, same power on top and bottom, use those coefficients. Limit's 1. Well, the limit's 1, we diverge. And finally, we take the limit of this one. The highest powered function is in the denominator. In this case, e to the n is more powerful than 3, and the limit is 0. But unfortunately, that doesn't help us prove anything. It is inconclusive. If this video helped you, please like and subscribe for more Calculus Try It videos. I'm also going to put a link here to a video if you want to see more examples of the nth term test or divergence test.